What if I told you that there was a way to fly through space without burning any fuel, but instead gliding silently through the cosmos? Take the Millennium Falcon, for example. Sounds like complete science fiction, right? Well, ionic thrusters are just that. Engines capable of reaching speeds over 200,000 miles per hour, and they only use a fraction of fuel required by chemical rockets. So brace yourself, because I'm going to introduce you to the mind-bending world of ionic thrusters. Let me explain it to you in 3 simple steps. Step 1, the ionization station. We start with a neutral gas, usually xenon. Why xenon? Well, it's inert, it's heavy, and does not react easily. Here we have a model of an ionic thruster with an electron gun that unleashes a barrage of electrons. These electrons collide with xenon atoms, knocking off their outer electrons. The result? Positively charged xenon ions ready for action. Step 2, the great ion acceleration. The ions are drawn towards a series of metallic grids which are charged with thousands of volts of electricity. As ions pass through, they are accelerated to mind-boggling speeds. We're talking about 90,000 miles per hour or more. Imagine going from Los Angeles to New York in under 2 minutes. That's how fast these ions are moving. Step 3, the big push. Then finally, these ions shoot out at incredibly high speeds, pushing the spacecraft in the opposite direction. Remember Newton's third law? Every action has an equal and opposite reaction. The ions are attracted to the negative grid and accelerated, creating the thrust, whilst negative electrons are attracted to the positive grid, so the particles can freely disperse in space. So what exactly does this all mean? This means that ionic thrusters are super efficient. They can keep pushing on for years on just a small amount of fuel, producing about 10 times more thrust for the fuel used compared to chemical rockets. Essentially, they have a very high specific impulse. And of course, less mass means less space, and more importantly, it means less costs. They're also less mechanically complex, making them a more reliable and low-maintenance choice. But of course, there are some downsides because nothing is truly perfect. The thrust produced by ionic thrusters is very small. We're talking about the amount of force of a sheet of paper pressing on your hand. This means it takes a long time to build up speed, so it's not great for quick maneuvers or launching off a planet. But in the vacuum of space, it adds up, since there is no air resistance. As you can see, the future is ionic. With their ability to continuously operate for years, they make interplanetary travel not just possible, but also efficient. They can also make our Mars mission a reality by cutting down on flight durations and fuel requirements. These engines are the real-world counterparts of the futuristic drives we have seen in movies, blending the cutting-edge physics and our dream of exploring the stars.